Hey, what's going on, everyone? It's Justin Dickmeyer from engineeringtrainingexam.com, and in this video we're going to review hyperbolas. The graph of the hyperbola takes two general forms. The first one we'll see is something like this, opening left to right, two curved lines opening left to right. Now the second general form is rotated 90 degrees and it's two curved lines, parabola-like lines, opening up and down. Now there's a couple characteristics that we should define of a hyperbola. One is an invisible line. It's not necessarily part of the hyperbola's graph. It's just important to know if we're graphing by hand so we can accurately graph the hyperbola. Now if you have a graphing calculator, obviously knowing the locations and the equations of these two lines isn't necessarily important. But if you are graphing the hyperbola by hand, then they definitely are important, because that's the only way you're going to be able to graph fairly accurately. Now these two lines are called asymptotes. And where they cross, which in this case is right here, it could be pretty much anywhere else, that is called the center of the hyperbola. Nothing fancy, just simply the center of the hyperbola. Now these 2 points, wherever the two pieces of the hyperbola peak or change directions, those two spots are the vertex of each of the curves. There's two in this case, so two need to be defined when you go and graph a hyperbola. Now each of these graphs have their own standard form equation. The one that opens right and left, the standard equation to this hyperbola is x minus h squared divided by a squared minus x minus k squared divided by b squared is equal to 1. Now the hyperbola that opens up and down, its general form is y minus k squared divided by b squared minus x minus h squared divided by a squared is equal to 1. Now there's a couple things that we can quickly define. If we're given an equation in either of these forms, we can quickly define a couple things. Number one, we can define where the center of the hyperbola is. And in both of these cases, the center is going to be located at hk. So if we're given an equation and we have numbers where h and k are, we can just quickly define the center of that hyperbola where those asymptotes cross. Now we can also quickly see how the hyperbola is graphed, what it would look like generally if it was graphed. We could just visualize it by seeing where this negative sign right here, what term is this negative sign in front of? For the graph, for the hyperbola that opens up left and right, this negative sign is going to be in front of the y term. It's going to be in front of the y term. Now the one that opens up and down, this negative sign is going to be in front of the x term. So if it's in front of the y term, it opens left and right. If it's in front of the x term, then it opens up and down. The next thing we can do is define where the vertex are, both of them. And that's going to be located in the one that opens up left and right. That's going to be located at h plus a, k, and h minus a, k. On the one that's opening up and down, those vertexes are going to be located at h, k plus b and h, k minus b. So notice there are two locations because a hyperbola has two curves, vertices, two of them. So the slope of the asymptotes, if you need to figure that out, the slope of the asymptotes for the one that opens left and right is going to be plus b over a, and the one that opens up and down is going to be plus b and a as well. Now you can take this slope and you can take where the vertex are of each of the parabolas, or sorry, the hyperbolas, and you can determine the equations for the asymptotes. Now, for the one that turns left and or opens left and right, I'm running out of room, so I'm just going to move over here. The hyperbola that opens left and right, the equation for the asymptotes is h is equal to k plus or minus b divided by a, which is the slope of the asymptote, x minus h. Now the equation for the one that opens up and down is going to be y is equal to k plus or minus b divided by a, x minus h. So what you see now is that the hyperbolas definitely share many of the same characteristics in the sense that they have the same slope for the asymptotes, it has the same equations for the asymptotes, and the centers are going to be the same. Now it's just how the general form is written that will determine whether the hyperbola opens right or left, or whether it opens up and down. So let's take a quick look at an example. Let's say we were given an equation and we were asked, once we were given this equation, to determine, number one, the orientation. Let's say we were asked to determine the center. We were asked to determine the vertices. We were asked to also determine what the equation was of the asymptotes. So let's say we were given an equation x minus 3 squared divided by 25 minus y plus 1 squared divided by 49 is equal to 1. So the first thing I would do now is first let's establish a and b. Now we know these terms down here are a and b squared. Now we know b squared is always under the y term, and a squared is always under the x term. So square root of 25 is going to equal a, and the square root of 25 is 5. And b is going to equal the square root of 49, which is 7. So now that we got those established, let's move on. We can determine the orientation right off the bat of this hyperbola. And we know that because what depicts that is this negative sign. And we notice that it's in front of the y, and since it is in front of the y, we know that this hyperbola is going to open left and right, just like this, something like this. This is going to be the general form, not necessarily centered on the x and y axis, but it's going to be opening left and right. So we can also see that the center of this hyperbola is going to be located at 3, 1, because we know this is h and we know this is k. So it's going to be located at 3, sorry, not 3, 1, 3, negative 1. So once we have the center, we can determine the vertices of on both sides, and we know that given our general equations, that one is going to be h plus a k, and the other is going to be h minus a k, and that is going to be, just put h in, which is 3, plus a, which is 5, and k is negative 1. So that's going to be 8, negative 1. And our second is going to be located at 3 minus 5, negative 1. And that's going to be negative 2, negative 1. So next we should get the slopes of the asymptotes. And these are always the square root of the number under the y term divided by the square root of the number under the x term. So the slope is always b over a, which in this case is 7/5. Now that we have all this information, all we need to do is to figure out the equations of the asymptotes, is plug in all this information that we've determined, and we know the general form of the equation for the asymptotes is y is equal to k plus or minus b over a x minus h. And so the equation is going to be y is equal to k, which is minus 1, plus or minus 7/5 times x minus 3. So that's it right there. All the information we would ever want about a hyperbola real quick. So that's it, guys. That is a quick review of hyperbolas and possible questions you may be asked on the exam. If you guys have any more questions or want to check out any more videos or have any more suggestions, some feedback or whatnot, once again, I'm here for you. Go ahead and head over to engineeringtrainingexam.com. Check out what I got over there and send me some suggestions through the contact, or go ahead and subscribe for the EIT preparation boot camp that I got over there. It's all yours for free. So for now, take care. Talk to you soon. Bye.